Telltale of COVID-19 apocalypse. It was 31st December 2019, the New Year Eve. WHO China office was informed of a pneumonia-like outbreak with 40-odd patients from Wuhan city who complained of fever, respiratory distress, cough, fatigue, and they were exposed to Wuhan seafood market, which primarily traded in live animals like bats and pangolins. On 12 January, China shared the genomic sequence of this virus as beta coronavirus. On 24 Jan, Lancet published its first paper stating the clinical manifestations of these patients. They had high cytokine chemokine expression, lymphopenia with a reduced CD4 CD8 T cell counts, high D dimer. It's a degradation product of fibrin, which is actually a readout of hypercoagulation, the hallmark of severe COVID patients. The patients also had ground glass opacities accounting for pleural effusion and ARDS, which leads to ARDS. The patients also reported of comorbid conditions like diabetes, hypertension, cardiovascular diseases. On 29 Jan, another paper came out stating the similarity of the sequence with a bat-derived virus and is phylogenetically distant to SARS and MARS, though they have similar manifestations. Now, bats are known to asymptotically harbor Ebola, Nipah, rabies, SARS. Now, what is so special about these bats? So, bats have a dampened inflammatory response. So, the sting pathway is downregulated, the JNF alpha pathway is downregulated, and also NLRP3 pathway is downregulated. Only interferon alpha is constitutively expressed. So, perhaps that's the reason how actually they take care of this virus by harboring it. It was early June, it was restricted to China itself, but by March end, it spread throughout the world. Why it is so infectious? The spike protein of the CoV2 binds 10 to 20 times stronger than the spike protein of coronavirus to the AC2 receptor, and the presence of furin recognition motif in the spike protein makes it more infectious. The course is in the primarily 80% of the population who are RT-PCR positive for SARS-CoV-2, they are asymptomatic, but the remaining 20, the severe and the critical, they need hospital intervention, the stage 2 and stage 3. Pathophysiology. So for the mild and moderate, it's the type 1 interferon which takes care with a low viral load and with the lymphocyte is in normal range, but with the inflammatory cytokines with not much of activation. But in the severe patients, it is actually the inflammatory cytokines which actually ramps up and causes the damage to the system, with the lymphocyte going down, and also the type 1 interferon goes down. So perhaps that's the reason which accounts for the exacerbated pathophysiologies. So it's actually the type 1 and the ISGs which are known to be suppressed. As we see here, if we move from severe to critical, the interferon production goes down, and also for the ISGs. So actually the virus, they outsmart the host system by suppressing the antiviral system of host, type 1 interferon and the ISGs. So they do it by the use of the non-structured protein 1. As we see here, when you are transfecting this NSP1, the luciferase translation is being inhibited, but the mutant one is not being inhibited. So it's a hyperstimulation of the proliferase cytokines which drives the disease towards severity. And it is interferon lambda which actually disrupts the lung epithelial barrier, which initiates the pathophysiology in a p53 dependent fashion. And p53 is also much known for its apoptosis role, but it is also known for its necrosis role. So in a artery occlusion where there is a blockage which leads to the mitochondrial dysfunction and necrosis of the lung tissue. There are also evidences which shows that actually during COVID-19 there are necrosis, as these signs are there of the lung epithelial and pneumocytes. And in fact, in COVID-19 there is the microthrombi deposition which is 9 times more than the H1N1, which leads to an impaired movement of the oxygenated blood, so that the gaseous exchange in the lungs gets impaired, which leads to ARDS. The dead cells also initiate inflammation in an IL-1 alpha dependent fashion. So IL-1 actually plays a very important role in blood coagulation too. So it is actually the IL-1 which is secreted from necrotic cells only. They binds to IL-1 receptor and signal downstream to activate the CXC chemokines, which are very important for the lung pathology to attract the neutrophils and macrophages to lungs, exacerbating the pathophysiology, and also IL-6. And also it can work in a paracrine fashion by activating IL-1 beta and amplifying the inflammation loop. So it's perhaps IL-1 alpha, which is generated first as a cytokine in a PP3 and interferon lambda dependent fashion. Then it can activate the important mediators for lung pathophysiology like IL-1 beta, IL-6, IL-17, and the chemokines. For therapeutic interventions, initially for the asymptomatic, antivirals can be perhaps good for only antivirals. And for severe and critical patients, anti-inflammatories along with antivirals and anticoagulants. To wind up, it is the suppression of the interferons coupled with the hyperstimulation which lead to the severity, and IL-1 can be a master regulator of the inflammatory cascade. And I gratefully acknowledge Dr. Fizigal and Dr. Golenberg for the initial insightful discussion, and also thanks to Dr. Tomar for the video edits. Thank you for your time.